Welcome to the Archaeoastronomy Database. In this video, we'll be looking at some useful markings in Stellarium. Now, some of the most basic markings are accessible down in the toolbar. You can turn on constellation lines and labels, and you can even turn on constellation art. And there's lots of settings that can actually change these up a little bit, and that's the topic for another video. There's also shortcuts that can be set for all of these for quick use, or you can use the toolbar down below. Also in the toolbar, you will have some grid options. You can turn on an equatorial grid that follows the celestial equator. You can turn on the azimuthal grid, which is local, with the zenith being the point in the sky directly overhead. And you can also turn on the ecliptic grid, which follows the line of the ecliptic. Now for all of these options, there's a more complete list under Sky and Viewing Options window, and in the Markings tab, which is the fourth tab over. And you can see here that there's already a check mark in the ecliptic grid, which I turned on down in the toolbar, so that can also be toggled on or off from this view. You can also choose custom colors for all of the lines, and you can set the thickness of these lines in this area here. Now with my custom color scheme that I've set up, it's intended to work well for my purposes, but everyone can set their own preferences. I usually set the color to black for options that I don't use, and gray for ones that I use infrequently. And then other colors match with other lines that they work well with. So for instance, I have here an option to turn on the ecliptic line of date. And you will notice that it's in red in the window. And I also have the equinoxes and solstices of date. So you might see that appearing right here if I toggle off the solstices. That marks on the ecliptic line where the sun will reach at the equinoxes and at the solstices. So if I were to advance the time backwards a little bit, the sun on December 21st, 2022 would be directly on that line, on that marking, and it will also be at 270 degrees on the ecliptic. So that's where the solstices and equinoxes occur. The vernal equinox at 0 degrees and the autumnal equinox at 180 degrees. Now coming back into the window, it makes it easy for me to toggle these on and off quickly by just finding the similar colors. You'll also note that there are secondary options that show the numbering and the partition lines, and these can be toggled off as well. But when you turn off this one, it leaves these other options checked so that they're already ready to go. And you can also thicken the partition lines here. In green, I have some useful lines for the local area. You can turn on the local horizon, which displays as a circle when you're looking at it from above or below, and when you're in a more zoomed in view, the horizon of course becomes that line. And you can turn on a meridian line, which runs from north to south, and there is also the prime vertical that runs from east to west, but I don't usually use that one. And of course this all matches up with the azimuthal grid. Along the horizon you can add the cardinal points, north, northeast, east, And you can also add compass marks with the azimuth degrees along the horizon. And these again all match up with the azimuth grid. And there are also options down here to toggle off the cardinal points and the compass marks. Another nice thing to know about the markings window is that whatever options you have set, if you uncheck this box, all the options other than the cardinal points will disappear, but can be toggled back on again. So if I were to have the ecliptic grid on, or any of these other grids, I could leave them in place and then toggle them all off for a moment, and then come back to the same settings just by clicking this button here. There are some other grids, like the galactic grid, that centers on the plane of the galaxy. And along with options like setting the ecliptic of date, you can also see that I've got in the same color the ecliptic pole. So there you can see the north ecliptic pole centered in the ecliptic circle. And if we invert the view, you'll be able to see the south ecliptic pole right there. I'm going to turn off the meridian. Another useful line is, of course, you can turn on the celestial pole, which is offset from the ecliptic pole, and that is centered on the ecliptic grid. So there's the south celestial pole, and here's the north celestial pole, where you can see Ursa Minor and Polaris very near to that north celestial pole. We'll turn off a few of these options. There's also an option for precession circles, which you can turn on, that show, both in the north and south, a kind of line drawn around where the axis of precession traces out the celestial poles in the sky. So if I were to turn back on the celestial pole of date, and the ecliptic pole of date is already on, you can see the ecliptic pole is centered in this circle, and the celestial pole is offset to the edge of the circle. And as time advances, you can see that the celestial pole remains in place, while Polaris, our current North Star, is no longer near the celestial pole. And in the past, you can see that the numbers along the lines take us to 1000 BC, 2000 BC, and 3000 BC. And those numbers trace back till 13,000 BC. And then this is actually 12,000 AD. So it goes about halfway around the circle of the roughly 25,000 years of precession, in one direction toward the future and in the other direction toward the past. And that's about the range of accuracy for Stellarium as well, with the settings that we currently have. Another useful option is to turn on circumpolar circles. These draw two circles that connect with the horizon locally, and so everything within this circle, for this position in the northern hemisphere, are stars that are circumpolar. They never rise or set. They remain in the sky, whether the sun is up or not. They're always above the horizon. And then looking toward the south, in fact, we'll turn back on our cardinal points. That was looking north for this northern hemisphere location. So a star like Vega at this latitude never rises or sets, remains above the horizon at all times. And now looking again to the south, within this circle are stars that never rise or set. They are below the horizon at all times. So a star like Canopus will remain below the horizon, never to be seen, except for more southerly locations. So we could demonstrate that by going to our map, and if I was to move to a more southerly location, you can see that this star is now just getting to the horizon, and now it's visible above the horizon. There are a few other options, like the anti-solar point, that I don't use very often. And when I am looking at eclipses, there's an option to turn on a circle that traces out the Earth's umbra, which is the darkest part of its shadow. We can find it really quickly. Here it is. And when the moon enters into that shadow, and I'll show you that it's actually on the line of the ecliptic, depending on where the moon and the Earth are positioned at that time. When the moon moves into that shadow, you'll have an eclipse. The options that I use most often are to keep the ecliptic on, along with the equinoxes and solstices of date, and I like to keep the meridian and the horizon on, and depending on the situation I may have constellation lines on or off. And I also most often use the equatorial grid, centered on the celestial poles and showing me the declination of various stars and other objects. With these options, I can always trace out the position of the sun in the sky and other objects that follow the ecliptic, more or less, such as the moon and the planets. And I have the horizon, and I'm able to know what direction I'm facing and how the sky is moving in relation to all these measured lines. So that's all for this video. Thanks for watching, and please support the Archaeoastronomy Database in any way that you can. Donations are greatly appreciated, and I'd like to thank all those that do donate. Please like, subscribe, and share. Thank you.